I'm Adam from RFOXiA from our real lab. Today we're answering why does almost every IoT build include a motion sensor and almost none of them include an air quality sensor, and whether that gap is an accident or a choice. Let me describe a very common IoT build. You have a microcontroller, you have an accelerometer, maybe a gyroscope, you probably have a temperature sensor because it was on the same chip and cost nothing extra. You might have a pressure sensor if you were feeling ambitious. You have GPS if the application demanded it, and you have absolutely no idea what the air around your device is doing, not the temperature of the air. You probably have that. I mean the quality of the air, the chemical composition, the particulates, the oxidizing and reducing gases that your device is sitting inside of or flying through or monitoring a space that humans are breathing in. None of that. Your device is completely blind to it. Now here is the interesting part. Air quality sensing is not a new technology. The ZMOD 4510 from Renesas, which is the chip on the Multinav Pro Plus Sensors module, has been commercially available for several years. The sensing principle, metal oxide semiconductor detection of oxidizing gases, has existed for decades. This is not emerging technology, this is not expensive, this is not technically difficult to integrate, and it is almost nowhere in the maker ecosystem. If you go to any major platform where developers share IoT projects, forums, GitHub repositories, YouTube builds, and you search for environmental sensor projects, you will find a very consistent pattern. Temperature everywhere, humidity very common, pressure reasonably common, air quality almost absent. And the projects that do include air quality are almost always using a single-purpose air quality module added as an afterthought, not integrated, wired separately, mentioned in one sentence of the project description. So the question is why? And I have thought about this because I am the kind of person who thinks about why the obvious solution and the correct solution are different things. The first reason is visibility. Motion is visible, temperature is feelable, humidity is noticeable, air quality is almost entirely invisible. You cannot tell whether there are oxidizing gases in a space by walking into it. You cannot tell whether the air quality around your drone's flight path is degraded without a sensor. Because air quality is invisible, it does not trigger the instinct to measure it. Builders measure what they can observe degrading. They do not instinctively measure what they cannot detect with their own senses. The second reason is ecosystem inertia. The BMI 270 from Bosch, the accelerometer and gyroscope on this module, is in every reference design. Every development kit has a motion sensor. Every tutorial starts with motion. So developers start with motion because that is what the ecosystem handed them. The ZMOD 4510 is not in most starter kits. It is not in most tutorials. So it does not get included, not because anyone decided it was not useful, but because the path of least resistance does not lead there. The third reason is that nobody has clearly articulated what you would actually do with air quality data from an IoT node. Temperature data is easy. You control HVAC, you log climate, you trigger alerts. Motion data is easy. You detect movement, you stabilize platforms, you measure vibration. Air quality data sits in a slightly more ambiguous space, and ambiguous is where builders stop. So let me be specific about what you would actually do with it, because this is the part that tends to clarify things. If you are building a drone, air quality data tells you what your drone is flying through. If you are mapping an urban environment, you now have atmospheric data correlated to GPS position. That is something that does not exist at street level from any public data source, and it is extremely valuable to environmental researchers, city planners, and logistics companies who want to understand pollution distribution at the block level, not the neighborhood level, not the weather station level, the block level. If you are building a fixed IoT node, a sensor station, a monitoring device, a smart home hub, air quality data tells you whether the space you are monitoring is safe. Elevated oxidizing gases in an enclosed space are a problem. That is information that temperature and humidity do not give you. If you are building anything that humans interact with, wearables, environmental monitors, indoor air quality stations, air quality data is arguably more important than motion. Humans are affected far more by what they breathe than by what orientation their wrist is in. And there is a fourth use case that I find interesting from a different angle. The RFOXiA data network pays you for sensor data that can be verified and sold to enterprise buyers. Temperature and humidity are valuable. Air quality data is significantly more valuable because it is significantly more scarce. The gap between what public APIs provide and what a verified street-level air quality reading provides is enormous. If your sensor node includes air quality, the value of every data session you contribute is higher than if it does not. So the absence of air quality sensing in most builds is not a technical limitation. It is not a cost problem. The ZMOD 4510 adds trivial cost to a module that already exists. It is not a complexity problem. So that is the gap. Invisible data ignored by almost every build for reasons that have nothing to do with whether it is useful. Now let me show you the hardware that closes it. This is the complete sensor array on a single board. Accelerometer, gyroscope, magnetometer, temperature, air pressure, humidity, and air quality, all 7. No peripheral modules, no additional wiring. Every data point the atmosphere and motion of your device can produce, available from one footprint. The board splits cleanly into 2 sensing domains. The motion sensors, BMI 270, TMAG 5273, give you platform awareness at the precision professional drones require. The environmental sensors, temperature, humidity, pressure, air quality, give you the atmospheric picture that almost every other sensor node ignores entirely. Both domains, one module. These are the component choices: Bosch BMI 270 for motion, Texas Instruments TMAG 5273 for magnetic field, ST Microelectronics LPS 22H for pressure, MEMS Vision MVH 4003D for humidity and temperature, Renissa's ZMOD 4510 for air quality. Each of these is a professional grade part. None of them is a compromise. All 7 sensors share a single I2C line. Each has its own address. You connect 2 wires and you have all 7 data streams. No address conflicts, no bus contention, no multiplexers. The wiring complexity of a single sensor with the data output of 7. That is what efficient I2C design looks like when it is done correctly. The board is 24 mm by 18 mm. That is the footprint of a large postage stamp. It fits on a drone frame. It fits in a wearable enclosure. It fits anywhere you have been putting single sensor breakout boards, except now it carries the full environmental picture instead of one slice of it. Size was not an accident. It was a design constraint. Every sensor streams in real time. When this module is connected to a live system, you are not polling averages, you are reading the environment as it changes. For air quality in particular, this matters. Gas concentrations shift quickly in dynamic environments. A sensor that gives you delayed readings in a changing atmosphere is not a sensor you can act on. The applications are not limited and not niche. Drones, environmental nodes, robotics platforms, indoor air quality stations, wearables, field research kits, data network contributors. If your build interacts with the physical world in any way, this module has something to tell you about it that no other sensor on your board currently can. Address, it does not interfere with any other sensor on the board. The absence is an awareness problem and an ecosystem problem. Builders are not including it because they have not been clearly shown what it does, and because the hardware they start with does not include it by default. The Multinav Pro Plus Sensors module includes a Renesas air quality sensor, so you stop treating the atmosphere around your device like it does not exist. That is the mission statement for this particular design decision, and it is one I stand behind completely.